on page 417, and on 417, all I want you to do is highlight this. That a log equation is an equation that contains the logarithm of a variable. So a log equation is an equation with a log where x is inside the logarithm. And we're going to learn how to solve these. And this is where all of our log laws, today you're going to find out where all of that practicing of log laws is going to come together. Remember, we practiced, sometimes we expanded things completely, and sometimes we wrote it as a single log. We're going to see both of those things in action today. And one of them, and the whole reason we learn those is so we can solve equations that we haven't solved before. This is one such equation. What's x? You look at that, I hope that nothing jumps out at you. It shouldn't. Sort of like, yeah, I have no idea. That should be the general reaction. That you should have no idea at this moment. So, the whole goal of solving log equations is using your skills to write things as a single logarithm. So do we have a single logarithm right now? No. We have two logarithms. Do we have a log law that could put those together? Yes, absolutely.
Two logarithms with the same base added together, you multiply the, forgetting what the word for it.
Yeah, you multiply the insides, which is called the arguments. So I can multiply 9x times x, agree that I would get 9x squared. And so now I have written this as a single logarithm. Now, I'm going to put a red star beside number 2. And this is the hardest step in grade 12 mathematics. It's not hard to do. It is just extremely hard to remember. Right now we have a single logarithm. Once you have a single logarithm, you can change to exponential form. The base is 3, the exponent is 4. And this is weird because in everything you've done so far in your life, in an equation solving, what you do to one side, you do to the other side. And in this type of equation, we do something different. We use a definition, and we just change its form. Because what we do to one side, we do to the other side. I can show you mathematically, there we go. I can show you mathematically what it would look like, but it's weird, okay? In other words, what we want to do right now is we want to get rid of the log. How do we get rid of the log? What could you do to both sides to get rid of the log? Don't write this down, but technically you could, I don't even know the word. What did I just do? We don't even really have a good word for this. I 3-based it. I exponented it. There's not good words for it. And then, technically, you have to know that exponents and logs are inverses of each other, so this would all cancel out and you'd just be left with that. That's too complicated an idea, so they say, well, it would be easier if we just said, use the definition and go from this part to this part. That's fairly straightforward. The base is 3, the exponent is 4, the answer is 9x squared. I just used the definition. But nowhere in any equation solving in your entire life have you had a step where like, oh, the next place what I do is I use a definition. That's very weird in equation solving. And so because of that, this step gets forgotten. It's going to be something you're going to have to study and memorize and think about because it's not intuitive. And most of equation solving is intuitive. And this is the first time you're doing something a little weird, like, oh yeah, I used a definition in the middle of a question. But once you've done that, now this is quite solvable. 3 to the 4th is 81. Right? I can divide by 9, x squared equals 9, square root both sides. Don't forget the plus or minus. So step 3 is we just, once we change it, it's just really easy to solve for x. But step 4, we're going to have to check, remember this word here, for extraneous roots. And I'm going to put in we're going to check for extraneous roots because you can't take the logarithm of a negative number or 0. You think about your log graph, right? Your basic log graph of any base looks like this. It has an asymptote here. Its domain is just when x is bigger than 0. So we got 2 answers. One was x equals 3, and one was x equals negative 3. And if I check them by plugging them into my original equation, if I plug in 3, I have 27 there and 3 there, that's fine, because I'm plugging positive numbers into my logarithm. But if I plug in negative 3, this one is extraneous. If on your exam, you go from this step and just write x equals 3, you have the right answer, and you would lose a full mark. You would lose a half a mark for not showing that x could be plus or minus 3, and a half mark for not canceling out the minus 3 as an extraneous root. Even though the answer is x equals 3, you haven't shown those key 2 steps. That you know that when you square root both sides, you have to remember the plus or minus, and you have to show that a root is extraneous by canceling it out. So it's a very important step in logarithms, this step number 4. Check to see if there are extraneous roots. Okay. So this is the basic idea for solving log equations. We want to get that single logarithm so we can use the step that you're going to forget. The whole purpose is to use the step that you're going to forget, which means once you have a single logarithm, that's when you're allowed to change it to exponential form. Then solving is easy, except you have to check. You're not allowed ever to take the logarithm of 0 or the logarithm of a negative number, so you could get an extraneous root. Copy this. Questions for practice on this one are 3, 4, and 9.